Hello! Today we're going to explore a powerful set of tools in mathematics, divisibility tests. By the end of this video, you will be able to use divisibility tests for 3 and 9 to quickly check if a number is divisible by them. You'll also learn a clever shortcut to find decimal answers for division problems that don't divide evenly. So, what are divisibility tests? They are simple, quick rules that help us determine if one number can be divided by another without leaving a remainder. In other words, they tell us if a number is a factor of another number. Why are they useful? Well, they can save you a lot of time. Instead of doing long division, you can apply a quick test. This is especially helpful for simplifying fractions, finding common denominators, and solving problems in algebra. Think of them as mental math shortcuts that make your life easier. Today we'll focus on the tests for the numbers 3 and 9. Let's dive in. Let's start with the divisibility test for 3. This is a very common and useful test. The rule is simple. A number is divisible by 3 if the sum of its digits is divisible by 3. Let's break that down. You take a number, add up all its digits, and then check if that new smaller number is divisible by 3. If it is, the original number is 2. Let's try an example. Is the number 459 divisible by 3? First, we find the sum of its digits. We add 4, 5, and 9 together. 4 plus 5 is 9, and 9 plus 9 is 18. So the sum of the digits is 18. Now, we ask, is 18 divisible by 3? Yes, it is. 18 divided by 3 is 6. Since the sum of the digits, 18, is divisible by 3, the original number, 459, must also be divisible by 3. Let's check with a calculator. 459 divided by 3 is 153. It works. Let's try another one. Is 7,285 divisible by 3? Again, we sum the digits. 7 plus 2 plus 8 plus 5. 7 plus 2 is 9. 9 plus 8 is 17. And 17 plus 5 is 22. The sum is 22. Now, is 22 divisible by 3? No, it's not. 22 divided by 3 gives a remainder. Because the sum of the digits, 22, is not divisible by 3, the original number, 7,285, is also not divisible by 3. If you were to do the long division, you'd find a remainder. So to recap, the divisibility test for 3 is to add the digits of a number. If that sum is a multiple of 3, the original number is 2. Now let's move on to the divisibility test for 9. You'll find it's very similar to the test for 3. The rule is, a number is divisible by 9 if the sum of its digits is divisible by 9. Just like with 3, you add up all the digits of the number. If that sum is a multiple of 9, then the original number is divisible by 9. Let's try an example. Is the number 242 divisible by 9? First, we sum the digits. 1 plus 2 plus 4 plus 2. 1 plus 2 is 3, 3 plus 4 is 7, and 7 plus 2 is 9. The sum is 9. Now, is 9 divisible by 9? Yes, it is. 9 divided by 9 is 1. Since the sum of the digits, 9, is divisible by 9, the original number, 242, is also divisible by 9. Let's check. 242 divided by 9 is 138. It works perfectly. Let's try another one. Is 5,371 divisible by 9? We sum the digits. 5 plus 3 plus 7 plus 1. 5 plus 3 is 8. 8 plus 7 is 15, and 15 plus 1 is 16. The sum is 16. Now, is 16 divisible by 9? No, it's not. 16 divided by 9 leaves a remainder. Because the sum of the digits, 16, is not divisible by 9, the original number, 5,371, is also not divisible by 9. You would get a remainder if you did the division. So to recap, the divisibility test for 9 is to add the digits of a number. If that sum is a multiple of 9, the original number is 2. Now for the clever shortcut. What if a number is not divisible by 3 or 9? We can still use the sum of the digits to find the decimal answer quickly. Here's the shortcut. The remainder when you divide a number by 3 or 9 is the same as the remainder when you divide the sum of its digits by 3 or 9. Let's see how this works for division by 3. We'll use the number 7,285 from before. We want to find 7,285 divided by 3. We already know it's not divisible. First, find the sum of the digits. We did this before. 7 plus 2 plus 8 plus 5 equals 22. Next, divide the sum of the digits by 3. 22 divided by 3 is 7 with a remainder of 1. This remainder of 1 is the key. It tells us that the remainder of 7, 285 divided by 3, is also 1. So, 7/285 divided by 3 is some whole number, plus a remainder of 1. We can write this as 7/285 divided by 3 equals some whole number plus 1/3. And we know that 1/3 as a decimal is 0.333. So the decimal part of our answer is 0.333. Let's try another one for 3. Find 1,000 divided by 3. Sum the digits. 1 plus 0 plus 0 plus 0 equals 1. Divide the sum by 3 to 1 divided by 3 is 0 with a remainder of 1. The remainder is 1. So 1,000 divided by 3 is some whole number plus 1/3, which is 0.333. Let's do one more for 3. Find 2/500 divided by 3. Sum the digits. 2 plus 5 plus 0 plus 0 equals 7. Divide the sum by 3 to 7 divided by 3 is 2 with a remainder of 1. The remainder is 1. So 2/500 divided by 3 is some whole number plus 1/3, which is 0.333. Notice a pattern here. If the remainder is 1 when dividing the sum of digits by 3, the decimal part is always 0.333. Now let's apply the same shortcut to division by 9. The principle is identical. The remainder when you divide a number by 9 is the same as the remainder when you divide the sum of its digits by 9. Let's use the number 5/371 from before. We want to find 5/371 divided by 9. First, sum the digits. We found this was 16. Next, divide the sum by 9. 16 divided by 9 is 1 with a remainder of 7. The remainder is 7. This means the remainder of 5/371 divided by 9 is also 7. So 5/371 divided by 9 equals some whole number plus 7/9. To find the decimal, we divide 7 by 9. This gives us 0.777. So the decimal part of our answer is 0.777. Let's try another one for 9. Find 1,000 divided by 9. Sum the digits. 1 plus 0 plus 0 plus 0 equals 1. Divide the sum by 9 to 1 divided by 9 is 0 with a remainder of 1. The remainder is 1. So 1,000 divided by 9 is some whole number plus 1/9, which is 0.111. Let's do one more for 9. Find 2/500 divided by 9. Sum the digits. 2 plus 5 plus 0 plus 0 equals 7. Divide the sum by 9 to 7 divided by 9 is 0 with a remainder of 7. The remainder is 7. So 2/500 divided by 9 is some whole number plus 7/9, which is 0.777. Notice the pattern here too. If the remainder is r, when dividing the sum of digits by 9, the decimal part is always r over 9, which is r repeating. Let's apply these ideas to a couple of homework problems. This will help solidify your understanding. Here's our first problem. A baker has 234 cookies and wants to pack them into boxes of 3. How many boxes can they fill, and how many cookies are left over? This is a division problem. We need to find 234 divided by 3. The remainder will be the number of cookies left over. Let's use our shortcut. First, sum the digits of 234. That's 1 plus 2 plus 3 plus 4, which equals 10. Next, divide the sum by 3. 10 divided by 3 is 3 with a remainder of 1. The remainder is 1. This means that when we divide 234 by 3, the remainder is also 1. So the baker will have 1 cookie left over. To find the number of boxes, we can do the division. 234 divided by 3 is 411.333. The whole number part, 411, is the number of boxes. Let's try a second problem. Problem 2. A group of 9 friends wants to split a restaurant bill of $153.72 evenly. How much does each person pay? This is a division problem. We need to find $153.72 divided by 9. Let's ignore the decimal for a moment and divide 15,372 by 9. First, sum the digits of 15,372. That's 1 plus 5 plus 3 plus 7 plus 2, which equals 18. Next, divide the sum by 9. 18 divided by 9 is 2, with a remainder of 0. The remainder is 0. This tells us that 15,372 is perfectly divisible by 9. There will be no remainder. Now we can do the division. 15,372 divided by 9 is 1,708. Since our original number had 2 decimal places, our answer will too. So each person pays $17.08. Let's quickly recap what we've learned today. We started by understanding that divisibility tests are mental math shortcuts that help us check if one number is a factor of another. We learned the test for 3. A number is divisible by 3 if the sum of its digits is divisible by 3. And the test for 9. A number is divisible by 9 if the sum of its digits is divisible by 9. Finally, we discovered a powerful shortcut. The remainder of a division by 3 or 9 is the same as the remainder of the sum of the digits divided by 3 or 9. This allows us to quickly find the decimal part of an answer. You are now able to use divisibility tests for 3 and 9 and apply a clever shortcut to find decimal answers. Keep practicing these tests and you'll find them incredibly useful in your math journey. Thank you for watching.